Hello everyone, welcome you all for this video. So in this video, we are going to be learn about the block diagram. Okay. So what are the things which is actually inside this 8051 microcontroller? Okay. So this is the complete block diagram of 8051 microcontroller. So we'll learn like what are the things which is actually inside that. Okay. And first of all, who introduced this 8051? It is by Intel in 1980. So it is uh know the thing. And what are the types of that means what type of microcontroller? So previous video we discussed there is a different type of microcontroller, 8-bit, 16 with 32-bit. So it is having a 8-bit microcontroller. Okay, so it can able to process 8-bit data at a time. So if you have missed out that video, so please watch it out that video, guys. Okay, the previous video. Okay, and it can able to process one 8-bit. Okay, so we'll do this one again. Okay, so if you want to be process one data, okay, for example, I'm having a 8-bit microcontroller. So in this 8-bit microcontroller, we previously know it is having a 8-bit processor. Okay, that means 8 bits which is having. Okay, simply I'm writing this one. Okay, this is complete one instruction, right? So if you just take it out, this is one instruction. You just consider this is one instruction. One instruction, it can process it can able to process one 8-bit amount of data at a time. Okay, so this is called as this one. And here, what is meant by mission cycle and everything we will discuss uh briefly. Okay, so one mission cycle, which means one instruction cycle. What we actually call it as a one instruction cycle is 1 to 2 mission cycle. Okay, depends on the mission. So how one mission cycle is equals to 12 clock pulse. That means you know the oscillator which is producing the clock pulse, right? So the oscillator is only thing which is producing a clock pulse. So in this scenario, if I want to process this 8-bit, I definitely require the mission cycle. What does mean by mission cycle? The clock pulse which is actually producing a clock. So your 12 clock pulse is equals to one mission cycle. Okay. So one mission cycle. This is the concept. So if I want to process this bit, if I want to process one instruction, I need one mission cycle. One mission cycle which is equals to 12 clock pulse. Okay, I hope you got clear about this one. Okay, in some cases, in some rare cases, one instruction might be to take 1 to 2 mission cycle. That means 24 clock pulse sometimes. Okay. So most probably just taking out the 12 clock pulse to process one instruction. Okay. So one mission cycle for this one. And next important parameter is what type of memory which is having. If you are going to be check it out, every microcontroller, not only this 8051, in every microcontroller, you just take this concept, your 8051 or AV pick, whatever microcontroller, you just take it out. It's just having a two type of memory. Okay. One type of memory, it is called as a non-volatile memory. So one type of memory, we call it as a non-volatile memory, and another type of memory, we call it as a volatile memory. Okay, so another type of memory, we call it as a volatile memory. Okay, those non-volatile memories and all can't erase it easily, right? We know that can't erase the data easily. Okay, but we can, once we can erase the data easily, because when you just pluck off it, automatically all the data is going to be erased. So if you just take it out any memory, any kind of microcontroller, you just take it out, it is having a two type of memory. So in this case, it is having a memory called as a non-volatile of ROM is there, which is about 4 KB, 4 kilobytes of non-volatile memory of ROM, and volatile memory of 128 bytes of ROM memory, RAM memory is there. Okay. 128 bytes of RAM memory is there. What is the difference? Why we are going to be using two type of memory? If you can ask this question, yeah. So all the microcontroller which is having a two type of memory of this like that. But what is the differences between these two is while you just process the data. Okay, you know the scenario, so how it is fetching the data. So that concept also, which is going to be comes to the next video. Okay, so CPU will be fetch the data. Okay, once you are going to be upload the code, so you know the sequence of this one. So if I'm going to be writing the code in any IDE, if I'm just writing a code in any IDE, okay, that code is going to be sent it into your microcontroller. Okay, that code is going to be uploaded in a microcontroller of the chip. So it is going to be uploaded on a chip. So inside the chip, it is having a two type of memory. That one is a non-volatile volatile memory. So once you're going to be uploaded the code, your code should be permanent, not going to be erased it off. So that's what the uploaded code going to be stored on this non-volatile memory. Okay, uploaded code going to be stored on this non-volatile memory, whatever it could be ROM. If you're going to be check it out the ARM Cortex STM32, it's just having a flash memory. It is going to be called as a non-volatile memory, right? So it is going to be store your data into your non-volatile memory first in beginning stage. Okay, once the processor is trying to fetch the data. Okay, so once the processor is fetch the data, so all the memory, all the data is going to be sent to the this memory to your processor because it is going to be processed, right? So once I upload the code, it is going to be stored on the memory. After while at the time of processing time, while at the time of processing time, the processor, this is your processor going to be fetch the data and going to be processed inside that. It is going to do the multiple function like arithmetic, logical unit functions and logical functions and many functions it's going to be performed. So this data is going to be fetched out from this to processor memory. But why this volatile memory is, so your data, okay, so the processor is going to be store some data for temporarily. Okay, so all your temporary data is going to be stored inside this volatile memory. Okay, for example, you're going to be write your code inside this when, so it is having a different section. So that is also we are going to be study. So if you just take it out a volatile or non-volatile memory, it is having a different sections called dot BSS section and a dot text section, dot data section, and a stack section, and heap section. So what the sections and all meaning means, so depends on your writing a code. Local variable going to be stored in the different section, global variable going to be stored in different section. So we will discuss this. And for it is going to be processed. So all the data, whatever the data just given by the non-volatile is going to be processed. So temporarily, it is going to be store all the whatever the data you're actually giving here. It is the processor which is using this temporary memory of volatile. It is going to be temporarily storing all the data into your volatile because whatever the data which you're giving, that is going to be keep on storing the data here for to temporarily store because it is going to be take some data and a process here. If you want to store some any temporary data, it is going to be stored on RAM and it's just fetching out the data. So continuously it is going to be use this volatile memory. Okay, because it does need to store all the temporary data and easy to fetch it out. So while compare this non-volatile, this volatile is very fast. Okay, easy to fetch the data and easy to process the data. Execution is very speed. So that's what we just going to store the temporary data on this volatile memory. Okay. So this is the two difference between. And what are the ports which is available? So commonly we are having a four parallel input and output ports. Okay, each which is having a 8-bit byte. That means, so normally what is the meaning of port means if you want to be communicating with the anything, okay, external peripheral you have been having, okay, if you want to be communicating with this external peripheral, you have to using a ports. Okay, so for example, if you want to be communicating with your friend, this is you, and if you want to be communicating with your friend, what you're going to be use? You are going to be use a mobile phone. So this mobile phone is called as an example port. It here you just consider mobile phone is going to be considered as a phone port. Okay. So same thing. Through that you are going to be speak to your friend. You are going to be receiving message to your friend. So this port is also same. If you want to be send the data to any peripheral, any sensor or any module, you through port you're going to be. And if you want to be collect the data from any sensor or any module, you're going to be which all the thing which is going to be happen with the help of the okay. So how many ports which is having a 4 port and each port which is having a 8-bit wide. So 8-bit wide means for if you just take it out port 0, it is having a 8 number of pins. If you just take it pin 1, it is having 8. So up to uh, 4 ports because it's starting from 0 up to 4 ports, it is each have 8 uh, bits. Okay, 8 bits wide. Okay. And next thing is your timer and counter. So what is the difference between this timer and counter? Where we are actually using this timer and counter? For example, you just take an example called as, and you just take a LED. Okay, you just simply take an example for as an LED. Okay, so this LED, if I want to be blink this LED, if I'm just studying the data sheet, it asks me to tell, it asks me to give like, if you just give the command of 1, if you're just setting the bit, specific bit as 1, the LED is going to be on. Okay, the same thing. If you just give 0 as your command, 0 bit, your LED is going to be currently turned off. Okay, it is going to be currently turned off. Okay, so this scenario is okay. Simply, if I'm just give the command as 1, it is going to be on, 0 off. What if I want to be sustained? If I want to be turn on my LED, LED is going to be on within this 0.05 seconds. So within this time period, within this duration, I need to be turned on my LED. Okay. And off. So this is on condition, this is off condition. I need to be turned off my LED within 0.03 seconds. Okay. So here both the thing which is telling the parameter called as an on and off duration. So the duration, if you want to be consider, you just go with this timer. So this timer which is going to be counting. Okay. So it will be whenever if you on the LED, okay, I'm just on the LED. But 1, I just give the bit code as 1, the LEDs get on. And while you're going to be mentioning the timer, okay, for example, using the delay kind of thing, if for example, if for 0.05 seconds, I'm just simply using the term called as 5, okay, 5 millisecond. You just consider. So you just keep your LEDs going to be turned on up to this 5 seconds. It just started to count 1, 2, 3, 4, 5. So on has been done. At the same time, if you want to be turned off the LED, just give the command as a bit 0. And now the LED is going to be turned off. And what is the range? What is the duration? Up to 2 milliseconds or seconds. So for this case, it just count the value 1, 2. So up to this range, it is going to be off. Again, it is going to be turned on. So if you want to be do this condition continuously, we can use the concept called as a timer with the help of this delay function. It is going to be vary by microcontroller to microcontroller. What about this counter? If you ask, whenever I need to be get the data from the external peripheral. For example, you just consider this is your processor going to be process the data. But this is the external module kind as ADC or UART or any communication protocol. I need to collect that data. For example, okay, analog to digital converter. For example, soil moisture sensor. So what the soil moisture sensor can do is it can converting your analog data. Analog means it is continuous with time. We can't read the data properly, raw data is only. So that data, if you want to be properly read, you just convert it as a digital. So this time, I just bring up this ADC. I'm just converting all the analog data to the digital data. This time, first of all, I'm just converting the digital data called as a 100. So 100, 101, 102, 1000. So kind of data is converting. So one after another. For example, 100 is called as a dry region. So if you're using a soil moisture sensor to finding out whether your soil is very moist or very dry, if it's too dry, just give the data called as 100. If you just too wet, 100, give the data called as 1,000. If in this scenario, for example, I've got the 100, I need to get the another data called as 1,000. What is the duration between these two data? For example, I've got 100. How long you just keep your data on your screen? For example, 5 seconds. So you are going to be use this time counter. Okay. So your microcontroller automatically using your counter for external event. Okay. For next data, I'm just to get within this duration. For after 5 seconds, I'm going to be get this data, and this going to be store stagnantly wait for 5 seconds. So this is how it is actually going to be varying, and yes, serial communication. So what do you mean by serial communication means whenever you want to be communicating with any external peripheral like this, you just go with this serial uh, communication protocol. Okay. And we already know that instead of communication protocol, we can use the ports. Through that ports also we can collecting the data. Why we are going to be using this communication protocol and all. So start with 0, which is having up to 4 ports of 3. Okay. Why we are go to the communication protocol? Communication protocol means the name itself it is having a protocol. So protocols which is in a sense which can follows the set of rules and regulations. Okay. So what is the distance of two devices? What is the speed of data you can going to be transmitting? How many pins you can able to use? It can reduce the pin sizes and all. Okay, instead of you just go with the ports for each and everything you're going to be sent with the different pins. But depends on the communication protocol you're going to be using, it is going to be reducing the pin size at all. Okay, so you're going to be check it out. There is a more thing advantages which is present in the communication protocols. So that's what. So what is the communication protocol which is available here? It is UART, that in full duplex. You can communicating both transmitting and receiving at the same time. And, and next one is interrupt. So we will see this concept and all detail in this upcoming session. So it is having a total 5 interrupt, 2 external interrupt, and 3 internal interrupt is there. Okay, and oscillator, we already know that oscillator which can producing the clock signals with help of crystal oscillator which can produce up to 11.059 megahertz. Okay, and so where this 8051 mostly used in applications is it is used in electronics, robotics, and many consumer electronics. It is going to be mainly performing this 8051 microcontroller. Okay, so that's it, guys. I hope you got clear on this introduction about this 8051 microcontroller, and thank you for watching our video. So we are going to be meet you on next video. Until it's goodbye from Charlotte. See you on next video. Bye, guys.